Hi everyone. This video we're going to look at radical equations and how to solve them. So again, it's a similar sort of progression. We learn about a particular kind of expression. We learn how to operate with it. We learn how to add, subtract, and multiply them. And finally, we make equations and see how to solve those equations. So let's look at a very basic one. If you're solving for x, given that the square root of x is 3, we apply the inverse operation, which is, in the case of square root, is squaring. So when we square this, you get root x squared is 3 squared, therefore x is 9. Okay, because the square root and the square cancel each other out. However, there is one small issue that we have to address here and thus be careful about. Here's the issue. Suppose we start with saying x equals 4, right? And then we square it and I get x squared minus 16. Now I subtract 16 on both sides, get x squared minus 16 is 0, but that is 16 is 4 squared. This is going to factor as a minus b and a plus b equals 0, which then becomes x minus 4 is 0 and x plus 4 is 0. The first of which gives x is 4 and the second gives x is negative 4. This means this is giving me two solutions, but we know that x is actually 4. Okay. So what happened here is when you square, you create new solutions which may not exist or which may not be valid, which means that when you're doing this process of squaring, you are creating more information, some of which may not be correct. So you have to be careful about interpreting your final result. So for example, in this case, after getting the final result, we can say that, well, although the solving gave us negative 4, it is not really a solution, which means that the solution must be only x equals 4. So we reject this solution. The point here is that for radical equations, I mean, in general, it's always a good rule, but especially for radical equations, always verify after solving. So by plugging into original equation. Okay, this is because when you square, you create new solutions or extra solutions, which may or may not actually be solutions. Let's look at some examples. There are very specific types of problems, and I have them here. There's three major types of problems. The first one is, so what is the type here? The type is square root of something equals a number. Okay, so this is straightforward. You just go and square both sides. So when you square both sides, you get root 2x plus 3 squared equals 5 squared, which then becomes 2x plus 3 equals 25. And now it's a regular equation that you can solve. 22, so x is 22 over 2, which is 11. So from this point on, it just becomes a regular expression that you generally solve. Once you have your solution, however, you do have to verify. So to verify, you check by plugging in 11 because that's the only solution. And this is 22 plus 3, which is 25, which is then 5, which is what it is. So x equals 11 is a solution. Okay, so this last step, especially for a radical equation situation, is extremely important. Let's look at this. This is also the same type, right? So with a slight modification. So it's square root of something plus a number plus minus another number. So here, prior to squaring, you just have to convert it to what it looked like before. So I subtract and I get x minus 3 equals negative 1. And now I square both sides. So that comes out to x minus 3 is, because negative 1 squared is positive 1. Plus 3 gives me x equals 4. However, I still need to verify. So to verify, I plug in 4. Square root of 1 is 1, which is not equal to negative 1. So there is no solution. Okay, so in this case, the result that we found does not give a solution. Now, a couple of things here to point out. When you have a square root and you're using it as a function, it always gives the positive value. Another reason why there is no solution is if you look at the starting point here, right, it says square root of something is negative. But by definition, when we use square root as a function, it can only give positive values. So this is not really possible, right? That's why it is a no solution scenario. Now, this is a new type. So this type is you have a variable and then you have something and then you have a number. Right? So in this case, do not square first. Okay, so you want to isolate the radical term first. To do that, subtract x on both sides. So you end up with 26 minus 11x equals 4 minus x. And now you square. Okay. So the idea here being that you're not going to square in the beginning because that's going to give rise to more complicated equations, but you're going to isolate the square root and then square because, well, the goal is to get rid of the square root. So it can only happen if you isolate the square. Now if you square, this is 26 minus 11x equals 4 minus x squared, which is then 26 minus 11x is 16 minus 8x plus x squared. Now you bring everything to one side, so you add 11x, add 11x. You subtract 26, subtract 26. So you get x squared plus 3x minus 10 equals 0, which you can now solve by factoring, because this is 5x minus 2x minus 10 equals 0, which is x times x plus 5 minus 2 times x plus 5, which is x minus 2 times x plus 5. X minus 2 equals 0, x plus 5 equals 0, x equals 2, x equals negative 5. Now, in this case, we get two solutions, which makes sense because the working equation was a quadratic. It's a degree 2, so there can be two solutions. But we still need to verify. Okay, so we have to verify that x plus square root of 26 minus 11x is 4. So when x is 2, 2 plus square root of 26 minus 11 times 2 is 2 plus square root of 26 minus 22, 2 plus root 4, 2 plus 2, which is 4. So that works out. What about negative 5? So negative 5 plus root 26 minus 11 times negative 5. That's negative 5 plus 26 plus 55, negative 5 plus root 81, negative 5 plus 9, 4. So both answers work. So these are both are solutions. Okay, so This is a different type because, well, the process is slightly different. We take x to one side and then square. As a result of that process, the equation that we finally solve is different. It's degree 2. And also, we have two solutions instead of one. Okay, now we have this one last sort of type here. In this particular type, there are two square roots involved. So here we are going to end up squaring 2 times. Still, we want to isolate one of the square roots before squaring. Okay, so for example here, I'm going to make it 1 plus root x plus 4, and then I'm going to square. Now squaring, the whole point was to get rid of this square root. This is going to be a squared plus b squared, so that gives me x plus 4, 2 times 1 times root of x plus 4. So I have 3x plus 1 equals x plus 5 plus 2 root x plus 4. Now I isolate the square root again. Okay, so I subtract x, subtract 5, subtract x, subtract 5. 2x minus 4 equals 2 times root of x plus 4. In this case, actually, I can factor out a 2 and cancel this out as well. And now we're going to square again. So this will be, now this reduces to our previous problem, right? It's a square root and then equals some x terms. So this is x squared minus 4x plus 4 equals x plus 4. Subtract x, subtract 4, subtract x, subtract 4. X squared minus 5x equals 0, which gives x times x minus 5 equals 0, which gives x equals 0 and x equals 5. Now let's verify it. Square root of 3 times 0 plus 1 minus square root of 0 plus 4 is square root 1 minus square root 4 is 1 minus 2 is negative 1. So no. So x equals 0 is not a solution. What about 5? Square root of 3 times 5 plus 1 minus square root of 5 plus 4 is square root 16 minus square root 9 is 4 minus 3 is 1. Yes. So only x equals 5 is a solution. Okay, so here's an example where once you solve, you get two values, but when you verify, it turns out that one of them is not the solution. So you have to be very careful that you do not forget to do the verification step. One last example here. Well, this doesn't fall into any of the types. The only reason it's different and I'm treating it differently is because here there's a cube root, right? Which means that to solve this, you would have to take a cube. So cube both sides. Okay, so the point that I want to bring across here is that, well, if it's a cube root, then you have to cube, right? You cannot square. And when you cube it, then the same sort of thing happens in the sense that the 1/3 and the third cancel, and you end up with 3x minus 1 is negative 64. Okay, and another thing here is, recall how we said that if you have a square root and a negative number, there is no solution. But remember, cube root means it's odd powered, and for odd powered, you can have negative, right? So that works out fine in the case of odd. And then you just do your regular step where you add 1, you get 3x equals negative 63, divide, and you get x is negative 21. then you can verify as well. To verify, you go 3 times negative 21 minus 1 cube root plus 4. Negative 63 minus 1 cube root plus 4. Negative 64 cube root plus 4. And that is negative 4 plus 4, which is 0. Okay, because remember, for cube root, you can take cube roots of negative number, and they come out to be negative. Okay, so slightly long video because I wanted to wrap everything up in one video, but that's pretty much it for this week. So you have the rationalization part and you have solving radical equations. Thank you, everybody.